In this video, we will explore the cumulative and relative cumulative frequency, and their distribution chart, and their relationship to the histogram. The relative cumulative frequency is calculated in a similar way as the relative frequency. Each value of the cumulative frequency is divided by the total number of values in the dataset. For example, the cumulative frequency of the first class is 23, and the total number of values in the dataset is 225. The relative cumulative frequency is 23 divided by 225 for a result of 0.102. The remaining cumulative frequency values are calculated in a similar way. Since each of the cumulative frequency values is divided by the same number, they remain proportional relative to one another, and we can plot the values using the scale on the right. Notice that just like the cumulative frequency is the running total of the frequency, the relative cumulative frequency is the running total of the relative frequency. As pointed out earlier, the sum of the relative frequencies is always 1. And an important property of the relative cumulative frequency is its maximum value is always 1. Remember, the area of each rectangle is plotted on the scale on the right, and is proportional to the probability of the class it represents. For example, the value of the relative cumulative frequency of the first class is 0.102, plotted on the scale on the right, and represents the area of the first rectangle, which has an area of 0.102. The value of the relative cumulative frequency of the second class is 0.187, plotted on the scale to the right, and represents the area of the first two rectangles, which is the sum of the first two relative frequencies. As you can see, the relative cumulative frequency, being a running total of the relative frequencies, is the sum of the area of the rectangles to the left of the class boundary. For another example, at the class boundary of 15.5, the value of the relative cumulative frequency is 0.311, which is the sum of the area of the first three rectangles, and is the sum of the first three relative frequencies. Keep in mind that the area of the rectangles is also probability, so we can express this as the probability of x being greater than 0.5 and less than 15.5 is 0.311. Here's another example. Let's look at the value of the relative cumulative frequency at 30.5, and notice its value is 0.667, which is the total of the first 6 relative frequencies, and is the area of the first 6 rectangles. From this observation, we can say the probability of x being larger than 0.5 and less than 30.5 is 0.667. Now that we understand that the relative cumulative frequency represents the area of the rectangles to the left of the respective class, let's see how to make use of this property. We know the area to the left of 30.5, as shown on the cumulative distribution chart, is 0.667. The area to the left of 15.5, as shown here on the cumulative distribution chart, is 0.311. It then follows that the area between 30.5 and 15.5 is 0.667 minus 0.311 for a difference of 0.356. Therefore, the area between 30.5 and 15.5 is 0.365 and is expressed as the probability of x being greater than 15.5 and less than 30.5 and is equal to 0.356. Here's another example. What is the probability of x being between the values of 25.5 and 40.5? We can determine from the relative cumulative frequency that the probability of x being between 0.5 and 25.5 is 0.542, and the probability of x being between 0.5 and 40.5 is 0.836. The probability of x being between 25.5 and 40.5 is the difference between these two values. Therefore, the probability of x being between 25.5 and 40.5 equals 0.836 minus 0.524 for a value of 0.294. and 0.294 is the area of these three rectangles. Let's now explore the area to the right of the class boundary. As noted, the maximum value of the relative cumulative frequency is 1, and is shown here on the cumulative distribution chart, and represents the area of the entire histogram. Let's go back to the example of the probability of x being greater than 0.5 and less than 25.5 equals 0.542. If we know this probability, we also know the probability of x being greater than 25.5 and less than 50.5. We know this because the total area of the histogram is 1. Then, the probability of x being greater than 25.5 and less than 50.5 must be the area on the other side of 25.5, which is 1 minus 0.542, and is equal to 0.458. Putting it all together, the probability of x being greater than 25.5 and less than 50.5 equals 1 minus the probability of x being greater than 0.5 and less than 25.5 is equal to 1 minus 0.542, which is 0.458. Let's do one more example. Let's find the probability of x being greater than 10.5 and less than 50.5. The probability of x being greater than 0.5 and less than 10.5 equals 0.187 is represented by the area to the left of 10.5. Therefore, the probability of x being greater than 10.5 and less than 50.5 is represented by the area to the right and is 1 minus 0.187 or 0.813. In summary, the value of the relative cumulative frequency at a given class boundary is the area of the histogram to the left of the class boundary. In addition, 1 minus the area to the left is the area to the right of the class boundary. The area between two class boundaries is the difference of the two relative cumulative frequency values.